Hey, what's up everybody? Christian here with another pfSense and WireGuard package update video. Today what I wanted to talk about is testing, and I wanted to demonstrate some of the ways that I continuously test the WireGuard package on a day-to-day basis, and also ways that I dog food the package on a day-to-day basis. So one of the things that I found to be really important while working on this project is actually being reliant on WireGuard in pfSense for connectivity for devices around my home. So this hopefully puts me in a position where if something doesn't work or something breaks, that I can actually have a really nice, test platform for triaging the problem, figuring out what went wrong, and coming up with a fix. So I am very committed to actually using the WireGuard package, in a really mission critical, scenario here in my home lab. And if something breaks, I'm going to know about it, and it's going to put me in a position where I'm inconvenienced. So that's kind of the whole goal, and being able to use that environment to troubleshoot and triage and hopefully come up with a fix. So what I wanted to do today is kind of showcase some of the ways that I actively test the package, several different scenarios that I include sort of in my test matrix on things that I test, kind of continuously. And I also want to demonstrate how I set that up, and hopefully it'll give you some ideas on some things that you might want to experiment with, as well as maybe even you want to deploy in your own home lab or even in your own corporate network. So let's jump right into it. So privacy VPNs are a really popular use case for WireGuard, not just in pfSense, but also in the VPN community in general. Privacy VPNs are really, really popular, and WireGuard has become sort of the de facto standard for transit for privacy VPN products. So the two privacy VPN providers that I actively test on a day-to-day basis is Mullvad and IVPN. I chose Mullvad because Mullvad has kind of become a very popular choice. Just going through Reddit and the Netgate forums, Mullvad kind of comes to the top as a very popular privacy VPN provider that people commonly use. And IVPN I chose honestly because somebody suggested it I think in the Netgate forums as another provider that some people were using. And I wanted to have, multiple providers so that I'm not reliant on one provider for testing, because if one provider is having issues, obviously it becomes difficult to ascertain whether or not the issue is with, something, WireGuard specifically related or something upstream with the provider. So I always make sure to have, redundancy in that department. In this case, I have Mullvad as a provider and IVPN. I would like to just briefly talk a little bit about some differences between these two providers, because it is kind of worth noting that these providers take a slightly different approach to how they kind of solve the key exchange problem, and it might actually influence how you pick a provider. Now, I'm not necessarily endorsing one provider over the other, and I know these are not the only two providers on the planet. There's nothing really special about these two providers. They're just two providers that, came to my attention as providers that people are using in the community, and I just kind of picked them. There is one really key important quality about these providers that you have to look out for, and that is providers that don't provide, standard WireGuard configuration files cannot be used with the WireGuard implementation in pfSense. There are providers like, I think NordVPN is one of them, that even though they advertise that their technology uses the WireGuard protocol, they don't actually provide you with a configuration file that you can, configure the standard WireGuard client on Windows or Linux or FreeBSD or pfSense. You have to use their client. And the likely reason for that is because they have solved the key exchange problem in a unique way, and they're doing lots of orchestration kind of above the WireGuard layer, the transit layer for the actual encrypted VPN traffic, and they're doing key exchange and IP address management at a different level, sort of like how ZeroTier uses the WireGuard protocol but it sort of abstracts that and just uses the WireGuard protocol as a sort of a framework or a tool to do, to pass traffic between nodes. But the actual orchestration of building up those tunnels and managing their life cycle is handled by, another layer of abstraction. So it's really important that when you're picking a VPN provider, whether it be Mullvad or IVPN, that your providers have to provide you with standard compliant WireGuard configuration files. If they don't, there is no way that you can use them in pfSense, because the pfSense implementation uses the standard WireGuard client under the hood. So you can't install, the NordVPN app on your pfSense box and use NordVPN. So if you're locked into a provider that doesn't provide a WireGuard configuration file, ouch. Hopefully you don't have a lot of time left on your subscription, and you can move to a provider that actually does provide you with standard configuration files that you can translate into the pfSense WireGuard package and use those directly in pfSense. So that's kind of one of the qualities of Mullvad and IVPN, is that both of these providers provide you with configuration files that you can use. Now, there is a difference, though, between Mullvad and IVPN that I think is worth noting, and that both of these providers actually solve the key exchange problem in slightly different ways. And I think that it's the differences between Mullvad and IVPN really come down to a privacy and a security difference. Mullvad solves the key exchange problem by generating private keys on your behalf and then transmitting those private keys to you in a configuration file. So that's not really the safest, process of doing the key exchange, because honestly, Mullvad doesn't need to know your private key. They just need to know your public key. But they insist on generating the private key for you, and then they, roll that up into a configuration file that you can download directly and load right into a WireGuard client, and just you're off to the races. So it has the added benefit of being able to, sort of just one-click import into a WireGuard client, like the WireGuard, Windows client, Linux, iOS, Android, whatever. But the cost of that is you compromise a little bit in security, because your private key is actually transmitted from Mullvad to you. So that's one of the main differences between Mullvad and IVPN. IVPN actually, they ask you for your public key. So you can actually generate your key pair locally in pfSense, and IVPN never knows your private key. You give them your public key, and then you in the server list, you pick the server that you want, and you grab the public key of that server, which is going to be the peer that you configure on the pfSense side. But IVPN never knows your private key. Other than that, they pretty much work the same. You configure them the same in pfSense. There's really no differences there. But I just thought I'd point that out. Again, Mullvad, they generate private keys for you. IVPN allows you to generate your own locally, and then you just transmit the public key to IVPN, and they never know your private key. So if security is and privacy is really your goal, keep an eye out for that. I haven't really played with any other providers besides Mullvad and IVPN, but I'm guessing that other VPN providers are going to take an either-or approach if they're providing, standard WireGuard configurations that you can download or configure. So just a little kind of note there to keep an eye out for that. I think IVPN does it a little better in that they allow you to generate your private keys and transmit the public key to them. So just something to keep an eye out for. So let's look at a network diagram of what I have set up here and what I'm going to demonstrate today. So I have a very simple setup. I have a NetGate. It's a NetGate 6100 connected to a single WAN connection. It's Comcast, and it's double natted. I don't have any static addresses there, so not the best, but it works. There's ways around that I might make some videos on later on how you can actually use WireGuard tunnels and a VPS provider like Amazon or Azure, and actually route static addresses from those providers and actually being able to use them locally and access them publicly without ever knowing that your network is behind, you know, a double NAT scenario like mine is. But that's a video for a future date. So I have Mullvad and IVPN configured on my pfSense. Again, this is a Netgate 6100. I have 2 tunnels, and then on the LAN ports, I have things configured a little bit differently. Obviously, the NG, the Netgate 6100, the LAN ports are not switched. They're actually discrete ports. So I actually have 4 different LANs. But I use this as an opportunity to provide different scenarios. So on LAN 1, which is the 192.168.40.0/24 network, that network uses the default gateway. So that's just going to use the WAN gateway. In this case, it's 10.0.0.1. That's the gateway of the Comcast modem or CPE. And that's what the LAN 1 port uses. So the 192.168.40.0/24 network uses just the pfSense default gateway. Now, for the other 3 ports, I'm using policy routing. So the routing policy for LAN 2, which is the 192.168.50.0/24 network, uses Mullvad as its gateway. So that's the routing policy for LAN 2. LAN 3 uses IVPN, and LAN 4 actually uses a gateway group to dynamically switch between Mullvad and IVPN in the case that one of those providers goes offline or has packet loss or latency or whatever. So that's one of the ways that I actually test the WireGuard package. Is we have what's more or less a site-to-site VPN between my pfSense instance and Mullvad, and my pfSense instance and IVPN, and then we use those gateways to actually route traffic from 4 different networks. Well, actually 3, because the LAN 1, the network behind the first LAN port it's just using the default gateway, and then the other 3 are using one or the other or both of the VPN providers. So let's actually look at how that's configured in pfSense. So the first thing we're going to look at is the WireGuard package interface. And you can see here that I've got my Mullvad tunnel, which is ton WG0. And then I have a test tunnel, which I'll talk about that in just a second. But ton WG2 is IVPN. And these are configured, you know, just using the configuration from both of those providers. Mullvad actually provides comp files that you can download, and then you can just copy and paste the settings between the configuration file and the WireGuard UI here in pfSense. IVPN's a little bit different because, again, you give them a public key. So you would actually go and add a tunnel, you would generate a key pair, you would copy the key on your side, and then you would paste that in to IVPN. Then they give you a v4 and a v6 address that you can use on this side of the tunnel. And then you go to their server list and you can pick, you know, the server that you want, and they give you an endpoint and a port as well as the public key of that server. So it's pretty straightforward. So there's really nothing special about this. I have Mullvad set up. In this case, I think both Mullvad and IVPN are using a peer that's in Chicago because that's geographically close to me. It's using US 232, and IVPN is using the Illinois 01 point of presence there. So one thing that's also really important to point out is not all VPN providers are going to use the typical WireGuard endpoint ports. So Mullvad does use the standard 51820 port for their servers. IVPN does not. And this is, I think, a pretty common mistake, especially people that are sort of used to the simplicity of WireGuard can overlook the fact that IVPN does not actually use any of the standard WireGuard ports. In fact, if you go to the IVPN guides, and if you go to, let me find that here. Actually, let me just Google that. IVPN does not use the standard WireGuard ports. So if you go to TCP and UDP connections, you can go to, let's see, probably should have looked this up beforehand. That's okay. this is off the cuff here. I know that, let's see here. Yeah. So if you go and search their help center here for, how do you change the port or the protocol? If you notice for WireGuard, they're not using the standard WireGuard ports, endpoint ports. They're using UDP. It's all UDP because WireGuard only supports UDP. They're using port 53, which is commonly used for DNS. So it's going to be a port that's probably open if you're behind a firewall that's quite restrictive. They're also using UDP over port 80, UDP over port 443. So again, common ports that are probably going to be open in case your ISP is actually blocking 51820 or 51821. Some ISPs are actively blocking connections using those ports. So that's one of the reasons why IVPN just avoids those ports entirely and provides ports that are more likely to be open. They're also using UDP over port 1194, which is commonly OpenVPN. And then there's an assortment of other ports. So there's a variety of ports to choose from, but 51820 is not one of them. So if you're using IVPN and you're pulling your hair out as to why you're not getting handshakes, you might want to check the port because it's very easy to race through the configuration and overlook that because you're so used to just using the standard WireGuard endpoint port. So that's really important. And then the public key for IVPN, again, you can just get that from their server list. So if you go to their server list, you can browse the server list and get the public key there, and also get the host name for the endpoint. In this case, it's us-il01.wg.ivpn.net. And then for both of these, because we want to actually use these for routing any potential traffic, you want to make sure to allow all for IPv4. And if you're going to use v6, you can allow doobly-doo/0 for v6. So that's pretty much it. And Mullvad's configured very similarly. Again, you grab the endpoint from the comp file, the port from the comp file, and the public key for that particular server. And again, the same thing. You need to allow 0.0.0.0/0 for v4. You can leave off the v6 allowed IP if you're not going to use that. The next thing that you're going to need to do is you're going to need to assign those ton interfaces, those ton WG interfaces, to an interface in pfSense. And the reason why you need to do this is because you're going to actually have to create gateway entries so that you can use policy-based routing. So this is one of the differences between why you would assign a WireGuard tunnel in pfSense versus why you would not. So if you actually need to do policy-based routing and route traffic towards out a WireGuard tunnel towards a peer, you're going to have to assign it in pfSense because you got to create that gateway, which requires an assigned interface. If you're doing remote access VPNs, that's not necessary. So that's one of the big differences between why you would choose to assign an interface versus why you would choose to leave the interface unassigned and actually configure the addresses through the WireGuard UI in pfSense. So in this case here, I have a test tunnel configured, and notice that I have the interface addresses defined here, and I don't actually have ton WG1 configured in pfSense. So pfSense is not aware of that network really exists. So there's some workarounds that we have to do for NAT and firewall rules to make that work, but we'll get to that in a second. So I configure the Mullvad WireGuard interface and the IVPN WireGuard interface. And then what you have to configure here is a couple of things. Number one is you need to choose static IPv4. And then you need to take the address from the configuration file that you're provided by your provider. And providers commonly use /32 addresses for these, which is totally valid because these are point-to-point links. And WireGuard's pretty special, and /32 addresses are completely valid here. But what that means is your gateway also has to be the same address as the interface address, which makes monitoring that address sort of dubious for anything useful. So to make gateway monitoring useful, you're going to need to monitor an address that is beyond your provider. So you can use, Google DNS, 8.8.8.8 or 1.1.1.1, or, the v6 equivalents. But that's kind of an interesting little, it's kind of weird that the gateway is itself, but that is what is required to actually get that traffic, going out the WireGuard interface, because once it lands on the interface, then the WireGuard crypto routing takes over and actually will send that traffic to whichever peer has that allowed IP block configured. So you're going to want to set that v4 address /32. If it's a v6, it's going to be a /128, and you're going to create a gateway, upstream gateway for both v4, and if you're using v6, a v6 equivalent as well. Now, because of the overhead in transmitting WireGuard packets, you're going to probably want to set the MTU to 1420, and then you're also going to want to clamp the MSS for TCP connections to 1380. Now, the pfSense UI is a little bit confusing because the MSS clamp is actually going to be calculated minus whatever number you type in here. So if you type in 1420, that's actually going to be clamped to 1380 because the v4 header is 40 bytes. So that's you're going to subtract 40 from 1420 to get 1380. You're going to subtract 60 for v6 because the v6 header is a little bit bigger, and you're going to get an appropriate MSS clamp there. So you're going to want to type in 1420 for both of these, and that'll give you an MTU of 1420 and a MSS clamp of either 1380 or 1360, depending upon whether you're doing v4 or v6. So that's what you're going to want to configure there, and then you're going to hit save, and then you're going to rinse and repeat for your other provider. So if we go to interfaces and look at the IVPN interface, it's the same thing, a /32, and we have a gateway for IVPN that is the same interface. Now, to make those gateways, the gateway monitoring useful, what you're going to want to do is you're going to want to set the monitor IP to be something beyond the interface address. Otherwise, the interface is going to be always up. So monitoring the local side of the tunnel is useless. So in this case, I have the monitor IP of 8.8.4.4, which is one of Google DNS's addresses. And then for IVPN, I have 1.1.1.1. So that actually makes the gateway monitoring useful in this case. So you can see here that I have a gateway widget that I've renamed to VPN gateways, and I'm showing the VPN gateways. So I have a widget for VPN gateways, and then I have a widget for actual physical gateways on my network, which again, according to my diagram, is just Comcast. So from there, what we need to do is we need to set up some firewall rules. Now, because we want to policy-based route traffic, what I've done here is under Firewall Rules, under LAN 1, remember that LAN 1 is just using the default gateway, so I just have a standard v4 pass all, and I'm not setting a gateway. So again, LAN 1 is going to use Comcast. So to demonstrate that, let me just take my WAN connection here, and I'm going to plug it into port 1 on my 6100. And we'll let it pull an address. Again, this address is under the 40.0/24 network. And if we go to IP chicken, you can see here that it's a Comcast address. All right. Now, if we go to LAN 2, which is the second LAN port on my 6100, you can see that I have basically the same exact rule, but in this case, I'm policy routing out of the Mullvad WireGuard gateway. So if I take my LAN connection, sorry about the microphone, I'm probably getting dim volume there. If I plug that into LAN 2 and let it pull an address, and I refresh IP chicken, you're going to see that I'm now connected to Mullvad. And in fact, if I refresh the Mullvad website, you're going to see that I'm now connected to Mullvad, the US 232 POP there. And likewise, if we go to LAN 3 and I have IVPN, so that port is policy routing out of IVPN. And if I go to IP chicken and refresh, you can see that my IP address has changed, and I'm now using IVPN. So if I refresh Mullvad, it's going to say that I'm not using Mullvad. But if I go to IVPN, it says that I'm connected to IVPN. And now the last test here is we're going to use a gateway group. So I don't think I actually showed you how that was configured, but if you go to routing and gateway groups, you can create a gateway group and you can configure it, whether or not you want to kind of round robin, between Mullvad and IVPN or whatever providers you're using, or you can give one a higher priority than the other, and you can set the trigger level. So in this case, I have the trigger level set as packet loss or high latency. So if one of these tiers has, high packet loss or high latency, that'll trigger the exclusion of that particular gateway from the group. And the configuration, again, very similar, following this pattern. We have a catch-all, and the VPN, or the gateway that I'm using is that VPN gateway group. So if we move that over to port 4, so this is the 4th LAN port on my 6100, and we refresh, we might not actually see the address change. Oh, we did. So it's trying Mullvad first, and because the states, there's a good chance that the TCP state for the web browser is going to stay open for a little bit longer. If I refresh this, it's probably, that connection really hasn't closed. So I'm going to get the same address. If I cleared the state table, I'd probably get a new address there. But we can actually use curl. So let me just open up a terminal window here. And if I just curl ifconfig.me, this is a service that just reports back your address. This actually doesn't keep an open state. So the first time I ran it, I got an IVPN IP address. And if I run it again, or I keep running it over and over again, you can see that my IP address is changing. So what's happening is it's using Mullvad for some connections and it's using IVPN for others. And I can just sit here and do this over and over and over again, and it's cycling between Mullvad and IVPN, Mullvad and IVPN. And again, because the policy for that gateway group is both gateways have a tier 1 priority, they're going to be kind of picked equally. Now, if I want to prioritize one over the other, it's pretty simple. Like, let's say that I want to use IVPN more than I do, Mullvad. I can set the priority for IVPN to be a tier 1, and then I can set Mullvad to be a tier 2 and hit save and apply. And now when I go back to my terminal, and let me just clear the screen here, I'm going to only get the IVPN. I'm only going to use the IVPN gateway unless the Mullvad gateway goes down. So we can test that too. So if I go to System and Routing, and I go to IVPN, I can actually just disable that gateway. Oops, hold on. I actually can't do it that way. I need to mark the gateway as down, so it's going to be considered as down, and hit Apply. And if I go to the gateway monitoring status, you can see that I forced it offline. And if I go to gateway groups, you can see that the IVPN tier is now been marked offline, and Mullvad, which is a tier 2, should pick up the slack. So if I go back to my terminal and I run that again, I should get the Mullvad route, which I do. So that's pretty cool. So we can go back to routing. Oops, go back to routing, go to gateway groups. Actually, I'm going to go back to this, and I'm going to unmark it as down so it's back up. Hit Apply. And let's make sure that it came back up. Yep, so again, I'm monitoring a remote address that's not local, so it actually is useful. Otherwise, again, it's just going to monitor the local side of the tunnel, which is useless for actually doing failover. If you don't actually set a monitor, there's nothing to actually monitor because the local side of the tunnel is always going to be up. So it's useless. Now, if you really don't want to actually use a foreign address, you can't actually use tiers because both tunnels are going to appear up. So it would only make sense in that context to have both set as tier 1. But it still doesn't do any good if both go down. So set a monitor address to make that useful. And I'm just going to set this back to make both of them tier 1 because that's what I want. So we'll go back here and we'll set this to both tier 1 and tier 1 and click save and apply. And we'll go back to curl and make sure that that's working. So we have IVPN and Mullvad, IVPN, Mullvad, IVPN, Mullvad, IVPN. So it's working. So that's pretty neat. So that's one of the ways that I test this. The other way that I test this is I test some remote access. Now, I'm behind double NAT, so I consider my WAN to be 10.0.0.0/24. So when I'm on, the Comcast network, that's sort of what I use as my WAN. I do test some other scenarios, but that's kind of the easiest because then I don't have to worry about touching Comcast's, crap. I can just test that as a WAN, and it simulates WAN just fine. But if we go back to the WireGuard configuration here, you can see that I have test tunnel. And if we edit that, you can see that in this case, I have not assigned it to a pfSense interface because I don't actually need to route traffic towards TUN-WG1 because I'm using this as remote access. In this case, I'm using 10.70.80.1/24 as the tunnel network. And then I have two different peers. I have my laptop and I have my phone. Now, I don't keep the laptop client enabled all the time, but I do keep the client on my phone enabled all the time. So that particular client is kind of one of the ones that I use for dog fooding this on a day-to-day basis. And that is I use the WireGuard iOS app using the on-demand VPN so that if I'm connected to my home network, that particular WireGuard tunnel is going to be activated. So, but to demonstrate this on my laptop, let's go through that. So the laptop address is 10.70.80.100. And because I don't, the only address that actually needs to go down this particular peer is the address that I'm going to use for the laptop. I'm going to use just a /32. So this is like a host address, right? A host route. And I have the public key of my laptop and I've assigned it to the test tunnel. And because technically, this tunnel, this device could have a dynamic endpoint, I'm not giving it an address, and I have a keep alive of 15 seconds just for kicks there. And again, the phone is going to be exactly the same, except for its address that I'm using is 1070.80.101. But again, it's a /32, and this is a typical setup that you would use for a remote access type of deployment. Now, there are some gotchas here, and I know this video is already it's already over 30 minutes, but I'm going to walk through this anyway. So because this interface, this test tunnel is not assigned to pfSense, pfSense is really unaware that it exists, which means there's a lot of semantics and logic in pfSense that would otherwise, automatically create NAT rules and other things. So we actually have to create those manually. So this 1070.80.0/24 network, if I route that out, if I actually try to use that and route that out my WAN, that network needs to be translated as it leaves, whichever WAN is configured. It could be my, Comcast WAN, or it even could be Mullvad or IVPN. Like I could actually have, a connection, a WireGuard connection from my phone to pfSense, and then I can actually route that over the connection from pfSense to one or both of the privacy VPN providers. But NAT's going to be required in either case. So if I go to Firewall and NAT, you can see what I have set up there. And in this case, for WAN, I have a source network of 1070.80.0/24. And for Mullvad and IVPN, I have the exact same thing. So if any of this traffic is sent out either the WAN interface or the Mullvad interface or the IVPN interface, if the source is from this network, it's going to have its source address translated to either be the WAN address or the Mullvad interface address or the IVPN interface address. Again, if you don't do this, the packet that you're sending is going to have a source address of 1070.80.0 or whichever tunnel network you're using, and that packet's not going to be able to make it back. So you've got to have these rules, and you also have to have at least hybrid outbound NAT rule generation enabled, because if you notice, the 1070.80.0/24 network is not one of the networks that's automatically in the list of source networks that's automatically created. And the reason why is because pfSense is not aware that that particular TUN-WG interface even exists, so we have to use some manual outbound NAT rules. But other than that, the firewall rules are pretty much the same. if we go to the Mullvad WireGuard interface, this is technically like a WAN interface, so we don't have to have any firewall rules there. We don't have to have any firewall rules for ingress traffic from IVPN. And we do have to have a firewall rule under the WireGuard interface group to actually allow traffic from, in this case, the 1070.80.0/24 network. And in this case, what you could see is that if I'm connected to the 1070.80.0/24 network, that WireGuard tunnel, it's actually then going to route that out the VPN gateway group. So it's actually 2 layers of WireGuard tunnels. It's a tunnel from my client to pfSense, and then there's the tunnel from pfSense to both of the upstream privacy VPN providers. So to just demonstrate that, I actually have the official WireGuard client set up here on my laptop, and my endpoint is just the it's just the LAN interface for my this is actually my home LAN. So let me actually flip that back to my home LAN. And let me let that reestablish. Make sure that we are still okay. So we're back on Comcast, and now if I activate this tunnel, you can see that we have handshakes, and this is a full tunnel connection. So I'm allowing all IPs from the WireGuard configuration on my laptop. So this is actually creating a route in the routing table on my Windows laptop here. And if I go back to IP Chicken, you can see that I'm now using, in this case, that's IVPN. And if I refresh, that state's probably still alive, so it's going to continue to give me that address. But if I go to curl, I can do the same thing. And you can see that we're, again, bouncing between IVPN and Mullvad. But the trick here is that it's 2 layers of WireGuard tunnels. It's the tunnel from my laptop to pfSense, and then there's the tunnel from pfSense to Mullvad and IVPN. So it's 2 different tunnels that this traffic is going through to make this work. And it works really well. So like if I do a speed test, this is 2 different tunnels. And if I run a speed test here, so that looks like IVPN, the throughput is absolutely fantastic. Like I can use this on a day-to-day basis, and I honestly forget that I'm even using a VPN. So, this is 300 plus megabits per second, and it works great. I think I actually get better speeds with Mullvad than IVPN, but it still works really well. And again, it's like I'm not even behind VPN, let alone really 2. One from my laptop to pfSense, and then one from pfSense to either privacy VPN providers. So that's just like a handful of ways that I actively test the package. Again, it works really well. So that's one of the ways that I actively test the package in a variety of scenarios. And again, I use this on a day-to-day basis. So if something breaks, I'm going to know about it, and I'm going to be inconvenienced, and I don't want to be wasting my time fighting it, so I'm definitely going to find a way to fix it. So that's kind of been my philosophy since day one, and I have a lot of fun testing the package out and doing that kind of thing. So let me just deactivate that, and then I should be back on my home LAN. Yep, and everything's good to go there. So yeah, so basically that's how I test the package. I push a lot of traffic through WireGuard. Not only just locally here on my network to test, different scenarios, but also between pfSense and different VPN providers as well. So hopefully this gives you some ideas on some things that you might want to experiment with in your home lab, and maybe you even want to configure failover between multiple VPN providers. So let me know how you're using the package and how you test the package. And if you have any suggestions for future content, make sure to let me know in the comments. Otherwise, we'll see you in the next video. Thanks.